So I just wanted to show you this next type of problem. This comes from modeling sinusoidal functions phase shift skill in Khan Academy. And so in this situation, we're going to have like a word problem instead of just here's a graph, make the equation, or here's the equation, make the graph type of problems. This is now a word problem, and we've got to, answer whatever they ask us to. Okay, so here we have a pendulum swinging next to a wall. The distance of the bob from the swinging pendulum to the wall varies in a periodic way. So my finger's the bob here. It's swinging, swinging. It gets closer to the wall, right? So the distance between it is very little, and then it gets much further away, right? So this is going to be the minimum of the function, and then it's going to swing away for the maximum. Okay. The function we get all these details about the function. It has a period of 0.8 seconds, an amplitude of 6, a midline at 15 centimeters, and at time at 0.5 seconds, when t is 0.5, the bob, here my finger, is at its midline, right? So it'd be halfway, and it's between its max and between its min, moving towards the wall. So it's at its midline and it's coming towards the wall. So we need to figure out how to put all this, and we can again use the little piece of paper that I gave you, the little template. Okay. What's weird here is that we want the equation. If you go back to the question, they're asking for the equation. And instead of starting with a graph like we have in past problems, they're just giving us all this stuff. So the first thing that they give us is the period, which is 0.8. Okay. When I look at it next, I see the amplitude is 6 centimeters. So I just put that in, 6 centimeters here. The next thing is the midline is at 15 centimeters. So I'm going to put that in, right? And, at time t equals 0.5 seconds, the bob's at its midline, right? So for us, this is going to be where we start our single version of the sine function, okay? So this will really be our phase shift. It's shifted over 0.5 seconds from a t of 0. So it's not on the y-axis. So I'm going to make the phase shift 0.5, okay? Now, the trickiest part of this is actually finding the equation form, which was pretty easy when we had the graph or whatever, or if we had the equation. It was easy to figure out what the equation form is. There's a couple of clues, though, they give us. So the first is that the bob, at 0.5 seconds, the bob's at its midline. That lets me know that I'm dealing with positive or negative sine. Because the two cosine functions, positive cosine starts at its max, right, at the function's max, and the negative cosine starts at its minimum. Sine, positive and negative sine, both start at the midline. So I know this much so far, because it starts at its midline. That's one version of the sine. It's either going to be positive or negative. Now I have to figure out if it's positive or negative. So I go back to the wording, and what's important is this right here, moving towards the wall. Now, if you think about the bob, right? The bob goes dun, 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 dun. This is the furthest distance away from it, so it's the maximum of the function. As it gets closer to the wall, the distance between the bob and the wall gets really small. So this is the minimum of the function. So we're told at 0.5 seconds, it's in between its maximum and minimum at its midline, and it's traveling towards towards the wall, which means it's traveling towards the minimum distance from the wall. That means that it's going down. So instead of normal sine function a positive sine function starts at its midline but goes up to its maximum. A negative sine function, right, starts at its midline but goes down to its minimum. So we know that we've got a negative sign here. Okay. Now it's all pretty easy. It's just a review of what we've done before in terms of turning all this information into an equation. Okay. First thing is we're just going to put in the easy stuff, right? This is going to be a negative sign. So negative 6 is the amplitude, sine of something. This is the harder stuff. The midline's at 15, so it's plus 15. Now we just have to enter in the phase shift and the period information. Those are always a little tougher for students. Okay, first thing is I'm going to put the phase shift in. Okay, what's important to remember, though, is to reverse the sign. So if the phase shift is positive 0.5, then in the equation, it's got to be negative 0.5. Okay. And there's also a trick when we're going to enter the period in, right? Right. If we want to enter the period in, we have to take 2 pi and divide it by the period. So 2 pi divided by 0.8 is going to be 2.5 pi. So that's what I put right here. And there is our equation for this problem. I hope that helped a little bit.